So it looks like we have another example where we're given some information about a region over which we want to integrate in rectangular coordinates. We want to switch to polar coordinates. We have a function, and there we're going to integrate to find the volume of the solid formed by the function. So we're told we're in the first octant, and that x squared plus y squared is equal to 1. So try to draw my x, y, and z axes. If this is my positive x direction and this is my positive y direction, then my first octant is going to be here between these two and up the z-axis, of course. I have the function x squared plus y squared equals 1, so I know that if I'm in the xy plane, that's a circle of radius 1 centered at the origin. So I'm going to draw that in here. And of course, dot, 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 dot. We're in the first octant, so we're really only concerned about this much. This is x equal to 1, this is y equals 1, and we're going to be integrating our function xy over that. So if it's in my xy plane, then it's just here. Okay. So the angle is, it looks like between 0 and pi over 2. I'm going to let my theta run. And the radius, I'm going to let it run from 0 to 1. So my integration is going to be 0 to pi over 2, 0 to 1. My function x times y should be r cosine theta times r sine theta. And then from my Jacobian, I get 1 more r, dr d theta. So that's 0 to pi over 2, integration 0 to 1, r cubed, sine theta cosine theta, dr d theta. And this is an integration we've done a couple of times now. 0 to pi over 2 first, r to the power 4 over 4, evaluated between 0 and 1. Sine theta and cosine theta are constant when we're talking about taking an antiderivative in r. So this becomes 1/4, 0 to pi over 2, sine theta, cosine theta, d theta. We've done this two ways. We've done it as a u substitution, and we've done it using double angle formula. Either one you like should give you the same answer. So let's say this is 1/4, integration 0 to pi over 2. I'm just going to say it's 1/2 sine 2 theta so that I don't have to worry about switching my bounds. Although as you saw when I did the u substitution, that's not bad either. It's actually pretty good, pretty simple. So this becomes 1/8 times minus cosine 2 theta over 2. The antiderivative of sine 2 theta is minus cosine of 2 theta over 2, evaluated between 0 and pi over 2. If I plug in pi over 2, I have cosine of pi, and cosine of pi is -1. Negative times negative is positive, so this is 1/8. I get 1/2 from plugging in pi over 2. And when I plug in 0, cosine of 0 is 1, so I get minus 1/2. And that's 1/8. So the answer to the problem, using a double integral in polar coordinates to find the volume of the solid, is 1/8.